The National Electrical Code, or NEC, requires ground fault circuit interrupters, or GFCIs, to be installed within 6 feet of sinks, bathtubs, and other wet locations. The GFCI can be mounted on the wall, countertop, or other approved location that provides easy access. The GFCI can be installed on the wall directly behind the sink, provided it is within 6 feet of the sink edge and is not obstructed by the faucet or other fixtures. The GFCI can also be installed on the backsplash behind the sink as long as it meets the following requirements. Firstly, the backsplash material must be non-conductive. Secondly, the GFCI must be recessed or protected from water splashing. Thirdly, the GFCI must be visible and readily accessible. There are some advantages of wall or backsplash mounting. Firstly, it allows easy access for testing and resetting. Secondly, it gives protection from potential water damage. Thirdly, it's aesthetically pleasing. Always consult with a qualified electrician to ensure proper installation and compliance with all electrical codes. When determining the appropriate location for a ground fault circuit interrupter or GFCI receptacle near a sink, several factors must be considered to ensure compliance with the National Electrical Code, or NEC, and to maximize safety. It is permissible to install a GFCI receptacle on the wall directly behind a sink, provided that certain conditions are met. The primary requirement is that the GFCI receptacle must be located within 6 feet of the sink's edge. This distance is specified in NEC to ensure that the GFCI can effectively protect individuals from electrical shock hazards associated with wet environments. The 6-foot radius is measured horizontally from the edge of the sink. Therefore, the receptacle must be positioned within this zone to comply with the code. Another crucial consideration is that the GFCI receptacle should not be obstructed by any fixtures or features that may impede access to it. This means the faucet, plumbing, or any other installation should not block the GFCI receptacle, ensuring that it remains readily accessible for testing, resetting, and maintenance. Accessibility is vital for ensuring the GFCI's proper function and the safety of users. Installing the GFCI receptacle directly on the backsplash behind the sink is also permissible, but it is contingent upon meeting specific criteria. Firstly, the backsplash material must be non-conductive to prevent electrical current from traveling through it. Common non-conductive materials include ceramic, glass, and certain types of plastic. Conductive materials such as metal should be avoided for the backsplash in such installations. Secondly, the GFCI receptacle should be installed in a manner that protects it from water splashing. This can be achieved by recessing the GFCI receptacle slightly into the backsplash or using a cover that shields it from direct water exposure. Reducing the risk of water entering the receptacle is crucial for preventing electrical faults and ensuring the GFCI's reliability. Thirdly, the GFCI receptacle must remain visible and readily accessible, even when installed on the backsplash. This means that it should not be hidden or obstructed by any objects or fixtures that would make it difficult to access for testing and resetting. The ease of access is essential for maintaining the GFCI's protective function. In terms of benefits, mounting the GFCI receptacle on the wall or backsplash offers several advantages. Firstly, it provides easy access for regular testing and resetting. GFCIs should be tested monthly to ensure that they are functioning correctly. A readily accessible GFCI receptacle simplifies this process and encourages regular testing. Secondly, installing the GFCI receptacle in an elevated position, such as on the wall or backsplash, helps to protect it from potential water damage. This is particularly important in environments where water exposure is common. By minimizing the risk of water ingress, the GFCI's lifespan and reliability can be extended. Thirdly, from an aesthetic perspective, wall or backsplash mounting can be more visually appealing compared to other installation methods. By integrating the GFCI receptacle seamlessly into the wall or backsplash, it can blend in with the surrounding decor and create a cleaner, more organized look. In summary, it is not a code violation to install a GFCI receptacle on the wall or backsplash behind a sink, provided that all relevant NEC requirements are met. These requirements include locating the GFCI receptacle within 6 feet of the sink's edge, ensuring it is readily accessible and not obstructed, using non-conductive backsplash materials, and protecting the GFCI receptacle from water splashing. Consulting with a qualified electrician is always recommended to ensure proper installation and compliance with all applicable electrical codes. To further elaborate on the technical aspects of GFCI installation and compliance with electrical codes, it's important to delve into specific sections of the National Electrical Code, or NEC, and related best practices. The NEC provides detailed guidelines on the installation and placement of GFCIs in various locations, particularly in wet or damp environments such as kitchens and bathrooms. One crucial aspect of GFCI installation is the wiring and circuit protection. According to NEC Article 210.8, ground fault circuit interrupter protection is required for receptacles installed in dwelling unit bathrooms, kitchens, and other locations where water is present. This requirement aims to protect individuals from electrical shock hazards that can occur when using electrical appliances near water sources. When wiring a GFCI receptacle, it's essential to follow the manufacturer's instructions and adhere to the NEC guidelines for proper grounding and bonding. The grounding conductor must be properly connected to the GFCI receptacle and the electrical panel to ensure that fault currents can be safely diverted back to the source. Bonding refers to the practice of connecting all metal parts of the electrical system to create a low impedance path for fault current. This helps to minimize the risk of electrical shock and fire hazards. In addition to the wiring requirements, the NEC also specifies the type and rating of conductors that must be used for GFCI circuits. The conductor size must be appropriate for the ampacity of the circuit, and the insulation rating must be suitable for the environmental conditions. For example, in wet locations, conductors with moisture-resistant insulation, such as type THWN or THHN, are typically required. The overcurrent protection device, such as a circuit breaker or fuse, must also be properly sized to protect the circuit from overload and short-circuit conditions. The rating of the overcurrent protection device should not exceed the ampacity of the conductors in the circuit. Furthermore, the NEC provides guidelines on the installation of GFCI receptacles in specific locations. For example, NEC Article 406.9 specifies the requirements for receptacles installed in damp or wet locations. These requirements include using weatherproof enclosures and covers to protect the receptacles from moisture and corrosion. When installing a GFCI receptacle on the backsplash behind a sink, it's important to ensure that the backsplash material is non-conductive. Common non-conductive materials include ceramic, glass, and certain types of plastic. If the backsplash is made of a conductive material, such as metal, it must be properly grounded to prevent electrical shock hazards. Another important consideration is the height and location of the GFCI receptacle. The NEC does not specify minimum height for receptacles, but is generally recommended to install them at a convenient height that is easily accessible. In the kitchen, receptacles are typically installed above the countertop at a height of approximately 44 inches above the floor. When installing a GFCI receptacle behind a sink, it's important to ensure that it is not obstructed by any fixtures or appliances. The receptacle must be readily accessible for testing and resetting. In addition to the NEC requirements, there are also some best practices to follow when installing GFCI receptacles. Firstly, it's always a good idea to consult with a qualified electrician to ensure that the installation is done correctly and safely. A qualified electrician can assess the specific requirements of the installation and provide guidance on the appropriate materials and methods to use. Secondly, it's important to use high-quality GFCI receptacles that are listed by a recognized testing laboratory, such as Underwriters Laboratories, OIL. These receptacles have been tested and certified to meet the applicable safety standards. Thirdly, it's recommended to test the GFCI receptacle regularly to ensure that it is functioning properly. GFCIs should be tested monthly by pressing the test button and verifying that the receptacle trips. If the receptacle does not trip, it should be replaced immediately. In summary, the installation of GFCI receptacles must comply with the NEC guidelines and other applicable standards. Proper wiring, grounding, bonding, and overcurrent protection are essential for ensuring the safety and reliability of GFCI circuits. Consulting with a qualified electrician and following best practices can help to minimize the risk of electrical shock and fire hazards. Considering practical aspects of GFCI installation, it is essential to understand the various types of GFCIs available and their suitability for different applications. The most common type of GFCI is the receptacle type, which is designed to replace a standard electrical outlet. These GFCIs are relatively easy to install and are suitable for use in most residential and commercial applications. Another type of GFCI is the circuit breaker type, which is installed in the electrical panel and provides GFCI protection for an entire circuit. Circuit breaker GFCIs are typically used to protect multiple outlets or appliances that are connected to the same circuit. A third type of GFCI is the portable GFCI, which is designed for temporary use in construction sites or other outdoor locations. Portable GFCIs are typically equipped with a cord and plug and can be easily moved from one location to another. When selecting a GFCI for a particular application, it's important to consider the voltage and current rating of the GFCI. The voltage rating must match the voltage of the electrical system, and the current rating must be sufficient to handle the load of the appliances or equipment that will be connected to the GFCI. It's also important to consider the environmental conditions in which the GFCI will be used. GFCIs that are installed in wet or damp locations must be rated for outdoor use and must be protected from moisture and corrosion. Installation of a GFCI receptacle typically involves removing the old receptacle and connecting the wires to the new GFCI receptacle. The wires must be connected to the correct terminals on the GFCI receptacle, and the grounding conductor must be properly connected to the grounding terminal. It's important to follow the manufacturer's instructions carefully when installing a GFCI receptacle. After the GFCI receptacle has been installed, it should be tested to ensure that it is functioning properly. The test button on the GFCI receptacle should be pressed to verify that the receptacle trips and interrupts the flow of electricity. If the receptacle does not trip, it should be replaced immediately. Regular testing of GFCIs is essential for ensuring that they are functioning properly and providing adequate protection against electrical shock hazards. GFCIs should be tested monthly by pressing the test button and verifying that the receptacle trips. If a GFCI fails to trip during testing, it should be replaced immediately. Maintenance of GFCIs is also important for ensuring their long-term reliability. GFCI should be kept clean and free of dust and debris. If the GFCI becomes damaged or corroded, it should be replaced immediately. In addition to the technical aspects of GFCI installation and maintenance, it's also important to consider the legal and regulatory requirements that apply to GFCIs. The National Electrical Code, or NEC, requires GFCIs to be installed in certain locations such as bathrooms, kitchens, and outdoor areas. Local building codes may also have additional requirements for GFCIs. It's important to comply with all applicable codes and regulations when installing and maintaining GFCIs. Failure to comply with these requirements can result in fines or other penalties. In conclusion, GFCIs are an essential safety device that protects individuals from electrical shock hazards. Proper installation, testing, and maintenance of GFCIs are crucial for ensuring their effectiveness. Complying with all applicable codes and regulations is also important for avoiding legal and regulatory issues. Consulting with a qualified electrician is always recommended when installing or maintaining GFCIs. To further clarify the guidelines and recommendations for GFCI installations, it's beneficial to consider specific scenarios and applications. For instance, in a kitchen environment, GFCI protection is typically required for all receptacles that serve countertop areas. This is because countertops are often used for food preparation and may be exposed to water or other liquids, increasing the risk of electrical shock. In addition to countertop receptacles, GFCI protection may also be required for receptacles that serve islands, peninsulas, and other similar structures in the kitchen. The NEC provides specific guidelines for these types of installations, including requirements for the number and location of receptacles. In bathroom environments, GFCI protection is required for all receptacles within 6 feet of the sink, as well as for receptacles that serve bathtubs and showers. This is because bathrooms are typically wet environments, and the risk of electrical shock is higher. In addition to receptacles, GFCI protection may also be required for lighting fixtures and other electrical equipment in bathrooms. In outdoor environments, GFCI protection is required for all receptacles that are accessible to the public, as well as for receptacles that serve swimming pools, hot tubs, and other similar structures. This is because outdoor environments are often exposed to water and other elements, increasing the risk of electrical shock. In addition to receptacles, GFCI protection may also be required for lighting fixtures, pumps, and other electrical equipment in outdoor areas. When installing GFCI protection in any of these environments, it's important to consider the specific requirements of the NEC and other applicable codes and regulations. It's also important to use high-quality GFCI devices that are listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. These devices have been tested and certified to meet the applicable safety standards. Proper installation of GFCI devices is crucial for ensuring their effectiveness. The wiring must be done correctly, and the device must be properly grounded. It's also important to test the GFCI device regularly to ensure that it is functioning properly. GFCI should be tested monthly by pressing the test button and verifying that the device trips. If a GFCI fails to trip during testing, it should be replaced immediately. In addition to the technical aspects of GFCI installation and testing, it's also important to educate users about the importance of GFCI protection and how to use GFCI devices properly. Users should be instructed to test GFCI devices regularly and to report any problems or malfunctions to a qualified electrician. Users should also be warned about the dangers of overloading GFCI circuits and of using damaged or frayed electrical cords. By educating users about GFCI protection, it's possible to reduce the risk of electrical shock injuries and fatalities. In summary, GFCI protection is an essential safety measure that protects individuals from electrical shock hazards in wet and damp environments. Proper installation, testing, and maintenance of GFCI devices are crucial for ensuring their effectiveness. By complying with all applicable codes and regulations and by educating users about GFCI protection, it's possible to create safer environments for everyone. Consider also the role of arc fault circuit interrupters, or FCIs, and their differences from GFCIs. While GFCIs protect against ground faults, FCIs protect against arc faults, which are a different type of electrical hazard. Arc faults occur when there is an unintentional electrical discharge between two or more conductors. These discharges can generate intense heat and can ignite nearby materials, leading to fires. FCIs are designed to detect arc faults and to interrupt the flow of electricity before a fire can start. FCIs are typically installed in electrical panels and provide protection for entire circuits. The NEC requires FCIs to be installed in many areas of the home, including bedrooms, living rooms, and dining rooms. While FCIs and GFCIs serve different purposes, they both play an important role in protecting individuals from electrical hazards. In some cases, it may be necessary to install both FCI and GFCI protection on the same circuit. For example, a circuit that serves a bathroom receptacle may require both GFCI protection to protect against ground faults and FCI protection to protect against arc faults. The combination of FCI and GFCI protection provides a comprehensive level of safety against electrical hazards. In addition to FCIs and GFCIs, there are other types of electrical safety devices that can be used to protect individuals from electrical hazards. These devices include surge protectors, which protect against voltage spikes, and ground fault indicators, which provide a visual indication of ground faults. By using a combination of electrical safety devices, it's possible to create a safer electrical system that protects individuals from a wide range of hazards. In conclusion, electrical safety is a critical aspect of home and building design. By understanding the different types of electrical hazards and by using the appropriate safety devices, it's possible to create safer environments for everyone. Consulting with a qualified electrician is always recommended when designing or modifying an electrical system.